What's up, scholars? Today we're going to continue our discussion of rigid transformations, rigid motion, and talk about rotation. We're going to spin some stuff. Cool? All right. What is a rotation? A rotation is a transformation in which a figure is turned about a fixed point. It's a transformation in which a figure is turned about a fixed point. What do we call that fixed point? Well, that's the center of rotation. Center of rotation. Rays drawn from the center of rotation to a point and to its image. So we've got two rays from that center of rotation to a point and to its image, form an angle called the angle of rotation. Angle of rotation. And a rotation is an isometry, an isometry. Isometry. What did that mean again? Well, iso, we know, means same. Meter means measure. So when we rotate something, we don't change its shape, right? We just move where it is. It's essentially the same shape, just moved. So it's an isometry. How can we turn objects? Well, we can turn them like a clock or not like a clock. So we can do clockwise, which would be like this. Or we could do counter clockwise, not like a clock, which would be the other way. I can't even draw it because it's so weird. No, I did that backwards. Not like a clock is that way. See, I told you it's weird. Going to the left, basically. We can abbreviate clockwise as the CW and abbreviate counterclockwise as CCW. CCW. To rotate our shapes, we need to know the 2 D's of rotation. First, we need to know the direction. Which way are we going? Direction. And we need to know the degrees. How much are we rotating it? How much are we rotating? And direction was which way? The degrees and the direction. After a rotation is performed, is the image going to be similar or congruent? Well, we said a rotation is an isometry. It's got the same measure, so that means it's a congruent shape. Rotations are isometries. Cool. All right. Let's rotate both of these letters, T and H, 90 degrees counterclockwise. Let's rotate 90 degrees counterclockwise. So let's give it a fixed point, our center of rotation. And we're going to rotate it 90 degrees counterclockwise. Means we're going that direction, 90 degrees. So our new T, there's the top of it. And here's this guy. There's our 90 degrees of rotation. We had our direction counterclockwise. Our degrees was 90. do it again with this H to give it a fixed point. Where's it gonna go? 90 degrees counterclockwise. Going up there. Now our H looks like this. Great job! We just did 2 rotations. Cool. Alright, let's talk about the symmetry. A figure has rotational symmetry if it can be mapped onto itself by a rotation of 180 degrees or less. So if you can spin it around and its new shape looks just like its OG shape in less than 180 degrees or 180 degrees, then it's got rotational symmetry. So, for example, a square, when we rotate it 45 degrees, well, that doesn't look exactly like its pre-image. So this is not the same as the original. That's not a Q that I want. I want an O. Let's just mark it off. But if we keep rotating it to 90 degrees, let's see what if I draw this line here and we kind of follow that line around. We rotated it 45 degrees, now it's over here. Rotated 45 degrees, now it's over here. But the original shape is the same as the new shape in 180 degrees or less. So this is the same shape as the original. So it's got rotational symmetry. Pretty cool. All right, let's cruise along. Cruising altitude. Triangle ABC is on our graph below. Oh, I see you there, buddy. I see you with your starting points, A and B and C. Okay, let's rotate you 90 degrees counterclockwise. So we're going this direction. Just like that. And then we're going to label our new points A prime, B prime, and C prime. Okay, 90 degrees counterclockwise. Going like this. So it was in the first quadrant. Right, that's our first quadrant. And it's going to move to the second quadrant. So A was up here. It's going to rotate 90 degrees and come down here. That'll be A prime, where A prime is going to be at -4, 1. Okay. And B prime was at 5, 2. It's going to rotate counterclockwise and go to -2, 5. B prime is at -2, 5. C prime was at 2, 0. It's going to rotate 90 degrees counterclockwise. I forgot to call that prime. So C prime is going to be at 0, 2. Here's our new triangle. Alright, that's great. That's pretty wonderful. Yeah. Okay, let's keep on going. Let's rotate it now 180 degrees counterclockwise from its original, or 90 more degrees from that second triangle that we made. So we're going to keep on going. A prime was at -4, 1. A double prime is what we're calling this, at 180 degree counterclockwise. And keep going. Over here now, A double prime is at -1, -4. Hopefully you're seeing a pattern because it's happening. B prime was at -2, +5. Rotate it counterclockwise. It's going to be at -5, -2, -5, -2. And C double prime was at 0, 2. C double prime is going to be at -2, 0. All right. Triangle number 3. Oh, you guessed it. We're going to go one more. And then we'll talk about the sneaky 4th turn. Rotate it one more time. 90 degrees more than the last one. So A double prime was at -1, -4. A triple prime is going to be over here. Boom, 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 boom. A triple prime is at 4, -1. B triple prime. B double prime was at -5, -2. It's going to be at 2, -5. 2, -5. And C was at -2, 0. It's now going to be at -2 for the Y, 0 for the X. And that's our new point to C triple prime. Yeah. What's going to happen if we rotate this one more time? Well, it's going to go right back to where it started, sillies. We know that. 360-degree counterclockwise, we'll go right back to where we started from. We'd be back up at A. Which would be 1, 4. B, which would be 5, 2. And C, which would be 2, 0. All right. Let's talk about these results in a table formation. See if I can put these two things together. I think I can. I think I can, and I think I will. I think it's going to happen. We're going to make a rule for all these rotations about the origin. Well. You guys are doing wonderful. Thanks for sticking in here, you know. Thanks for being here. Thanks for doing this. Yes! Yes! It all is going to work out. Cool. We rotated 90 degrees counterclockwise about the origin. What happened with these coordinates? We went from A was at 1, 4 to A prime was at -4, 1. So we flipped the coordinates and changed the sign of the first one. So we went from x, y to -y, x. We flipped the coordinates, right? We went from 1, 4 to -4, 1. So we flipped the coordinates and made that sign negative. When we did 180 degrees rotation counterclockwise about the origin, we went from 1, 4 to -1, -4. So we flipped the signs on both of the original numbers. To 70 degrees, 1, 4 to 4, -1. So we flipped the positions and changed the sign of the y, new y coordinate. And 360 degrees, that's the same one. The same thing. All right, scholars, that's all the info. You're going to finish the notes Love you so much. Hustle, hustle.